Hey, welcome to Accelerate Your Smart Factory with 3D Visuals. My name is Jim Zwica. I am the Director of Manufacturing Solutions here at Vertex. My entire career actually has been involved with creating 3D engineering data and then uh, putting it in a position to be utilized, to be consumed in a way that has improved processes and engineering efficiencies for 20 plus years. I was in charge of doing 3D visualization and digital prototyping at Ford Motor Company for a very long time. And then most recently, I was at Caterpillar integrating 3D visual data into PLM solutions and manufacturing CAD solutions and processes, again, with the intention of improving all of the use cases that involve the creation of products and then how they flow through a factory and be made efficiently, all the way down to actually service and customer experience. And so what I wanted to do is talk to you guys a bit about what we're doing today, what's out there today in the context of a factory specifically, and what are the opportunities to actually start and visualizing 3D information and some of the barriers that have existed today to prevent that from happening, and then what the overall opportunity is. So let's go to the positive side of this and think about like what's possible, like what could you do if you actually have a digital twin of your factory. So first of all, most common thinking with a digital twin is on the product side. So the car or the tractor or the whatever, you have a digital twin that is aligned to the product and that a customer may own. But just as important, and considering the amount of information that's accumulated in the context of building a product, the factory itself is its own digital twin as well. And what you want to do is kind of have those two work in a synergistic sort of way. So you'll have the product digital twin flow through the digital twin of the factory. And then you want the information that's accumulated to be able to be really consumed in a way that will highlight issues or highlight problems or highlight material flow, all the things that traditionally weren't aligned. So they were being accumulated. So you had systems, you had data that, systems that were accumulating this information, but generally it was on, maybe the operators on this fixture or this route or this station to do something against, versus having a digital twin of the factory itself where you could make it more actionable, as opposed to reacting to it. You're able to proactively see problems, address them, fix them in advance. So predictive, you hear predictive maintenance a lot. So in this case, putting yourself in a position to have this information, be able to predict what's going on, react to it, and then of course prevent the line from going down, which is always a very, very bad situation. So let's think about some of the things that you can do. How do you bring this data to life? How do you improve the end user experience? And then again, making the data more actionable or interactive. So, if you think about a factory, there's many routes, there's many stations, there's other sort of support areas that need to react to things that are happening across the floor. And all of that information has typically been siloed off or accumulated in those groups, but not made available to the rest of the community or the rest of the groups that are the workers on the floor, the manufacturing engineers, the industrial engineers. They needed to have access, or they need to have access to information, but perhaps they're only looking in their ERP system, or they're looking in their MES system, or they are working in the context of what they've had available to them historically. But really, the value of this twin with respect to the factory is to take this information and then align it to the 3D representation of the factory. So if you have a fixture, you would like to have the relevant information be aligned to that, and then which will then allow you to really see in a visual way. Visual meaning that you have a 3D piece of geometry that could show health, for example. I'm green, so I'm good. I'm yellow, there's something going on here, I'm red. And be able to see that in the context of the entire factory so that you can notice if something is not healthy, that you can go in and look at it. And as opposed to looking at these discrete sets of data and then trying to mine through it and then infer what's going on. So like if you have and-on systems that are blinking or that are gathering information and putting it into your ERP system, that may be something that you only notice at the end or when things are really, really bad. Where if you have a digital twin of your factory, that information can feed in, it can go through the sort of configuration, solving, triggering mechanisms to say, hey, if this set of data comes in, I need to inform this person. But if you could take that and then just show almost like a heat map or a health map of that floor, people could really see overall what's going on. And then if they needed to hone in on that data, they could do that. And so a couple of things that you think about when you think about visualizing your factory floor, you have material flow, you have optimization, logistics, you have the plant layout, all of this you want aligned to this information. And then you're going to have multiple different groups that need to see this information in a way that makes the most sense to them so that it's actionable. So like I said, if there's a certain routing or a certain station that's running out of material, that may be fine for them, or they may have to raise awareness, but the ripple effect to that. So like if they are turning red, for example, you could see if you have a 3D twin of the factory, you are able to see how that domino effect is impacting the rest of your factory, and you're able to work on it in a good way. And humans of course are visual. It's easy for them to see 3D objects to help them make decisions quickly. And that's really the whole intention of this twin, is to be able to enable essentially reams of information that would be kind of hard to make heads or tails of, especially for the operators to do actionable sort of work and keep the line up and keep it going. And then another aspect to building a twin for your factory is that it's very reusable. So as every group is able to use it in their context. So think about 3D work instructions. You may want the product to come in at a certain build state, in that fixture, so that if your operator has some question about how this thing must be assembled, and they're able to have a 3D work instruction where they can take it, manipulate it, zoom in, tick through the work instructions and see the parts come in. It really helps them with today's world where you don't just get the same configuration come through anymore. Oftentimes, multiple configurations are coming across during a given workday, and they need crystal clear 3D interactive work instructions to help them ensure that they have good quality assembly, so that there's not trouble either further down the line during the assembly, or worse yet, in the context of a customer having a poorly assembled product that becomes a serviceability nightmare. And so you want, when you have a digital twin of both the product and the factory, you're able to really help them figure this stuff out in a way that's actionable during assembly. That's really, really valuable. So those are some of the opportunities that you have when you build a digital twin for a factory. And they're probably pretty obvious and very valuable. It would be hard to dispute that. So then why aren't companies actually doing this? And oftentimes, actually, the 3D data is extremely, to put it gently, it's extremely hard to work with. First of all, let's assume that it's made. Oftentimes a factory could be 30, 40, 50 years old, way before 3D CAD was ever a thing. And so it may not exist. And then if it doesn't exist, oftentimes what will happen is they will take a 3D, like a laser scanner, put it on the back of a golf cart, and then go through. And then what you end up with is an extremely large set of information that would require a lot of processing to make available to the users for consumption. And in order to do that successfully today, again with today's solutions, it requires very expensive hardware and software. And also you have to then process that information, process that factory in a way that it's broken up so that you can make sure that the digital twin data actually goes in against the cells, the routings, that sort of thing. And so there's a bunch of administrative work. The data sets themselves are huge, and therefore most haven't gone to the trouble to really build out a factory for this. Now that's changing, of course. Now a lot of factories are using manufacturing CAD solutions. So even if you don't have the full factory in 3D CAD, what they will do is they'll kind of mix the 3D laser scan with certain strategic areas where they will make 3D CAD assets to help facilitate the digital twin events or the digital twin value that you want to get out of it, which then allows you to bring in your sensors, your andon systems, all of your MES, your ERP, all of that information can then be aligned to the 3D assets so that you can create these digital twin, living digital twin factories to help you make good decisions and get value out of them. But in order to achieve that today, again, with existing solutions, is that it's very expensive hardware and software. And generally speaking, companies haven't made the investment in the manufacturing space to let this come to life. And so as a result, the manufacturing companies often don't get a chance to leverage the opportunity that you get with a digital twin. And then, the factory itself is going to be very, very large, but the actual data that is flowing through the factory, again, talking about ERP and MES and the andon systems, everything like that, is so massive, and it's delivered only in a way that the operators of each fixture, of each route and station, they're making kind of tactical decisions on the fly, but it's not being accumulated in a way that you can see the big picture. And so that's again another reason why people won't be leveraging a factory digital twin. Now, that being said, all of this is changing. A lot of effort is being spent in eliminating all of these barriers. The ability to bring in massive amounts of information that not only exists in a expensive piece of hardware and software, but they're also it's getting built in a way that we can be device agnostic. So you can actually use an iPad, you can use your phone, you can go through here and go through the factory. Even as you approach a station, it'll know where you are and it'll bring up that geometry for you, and it'll give you health of it and like dashboards. And so there's a lot of effort being done to eliminate all of these problems. And that's really, as far as Vertex is concerned, there's a lot of interesting opportunity there to address these issues, address this pain, and really show how you can make your digital twin, factory digital twin, come to life. And so if you're interested in hearing more about what is possible and what you can start doing and how you can start bringing your data together, then by all means send me a note, or whoever's manning the booth to us, and we would be happy to have a deeper discussion with you on this. So my name is Jim Zwica, and thanks for taking your time to listen to us.